Okay, we are still looking at right triangles, but we're going to look at yet a new way to find sides and angles. So these are called trig ratios. So these are for not special triangles. If you have a 45, 45, 90, a 30, 60, 90, you can still use those rules. If you have two sides, you can still use Pythagorean theorem. But this is going to be for triangles where you get one side, and an angle that is not 30, 60, or 45. So today, all we're going to do is learn how to write this, how to set it up. Next time, then we'll start putting things in the calculator. So today is just, what is this and how do I set it up? So, for trig ratios, trig is short for trigonometry. You're going to get a little glimpse of trigonometry this week, and then you won't see it again till pre-calculus, I think, maybe. I don't remember. So here's what you need to remember for trig. We've got a funny set of words that we're going to learn called SOHCAHTOA. So this is going to help us remember how to set these up. So for each one, we're writing a fraction. So we'll use the S, we'll use so, it stands for sine, and this is going to be our opposite side over the hypotenuse. I will tell you what all of this means in a minute. All right, so is sine, opposite over hypotenuse. Ca is for cosine. And this is for the adjacent side over the hypotenuse. And then, I'm going to scoot TOA over a little bit. TOA is for tangent, which is the opposite side over the adjacent side. I'm going to abbreviate those so it takes up less space. So all of these, you'll see shortened. Sine, you'll see it'll look like sin, S-I-N, but it's still sine. Cosine will be just C-O-S, the first three letters. And tangent, you will see as tan. So these are like your rules for this. So this is, you'll want to keep this to where you can see it and know SOHCAHTOA, sine, cosine, tangent. All right, we're going to start with sine, then we'll look at cosine, and then tangent. And again, it's just setting it up today. So all we're looking at is writing these fractions. All right, so here is our first set. So what you can see here is in every triangle you get for this, you will have one angle that'll be given to you. The side that is right next to that angle is your adjacent side, and then the one that is across from it is your opposite side. The hypotenuse is always RC. It's always across from that right angle, every time. So for sine, we want to remember opposite, so that's what the O is for, over the hypotenuse. That's what the H is for. I want you to see hypotenuse there. So if we look at number one, our first example, the first thing we need to find is our angle. So here it's got X here, and it asks us for sine. So that tells us that we want our opposite over the hypotenuse. So our opposite, if I go from x, I want to go across. I want to go opposite from it. So that is 5. So on top, I will have 5. And then our hypotenuse is always across from our right angle. So here's my right angle, and my hypotenuse is 13. So 5 over 13 would be the answer, and that's where we leave it. Let's look at number 2. Again, look for that angle. So our angle this time is right here, and it's asking for sine. So if we think about sine is opposite over hypotenuse. So let's start with opposite. Here is y. Opposite, I want to go across from y, and I get 6. 6 is across. So I'm going to put 6 with opposite, and then our hypotenuse is always across from the right angle. So here's my right angle, so my hypotenuse is 10. So this time, 5 over 13, we cannot make that smaller. If we put it in the calculator, you'll get 5 over 13. But 6 over 10, we can simplify this. These can both divide by 2. 6 divided by 2 will give us 3. And 10 divided by 2 is 5. So the final, most simple answer is 3 over 5. So again, sine is the opposite side over the hypotenuse, over C. All right, let's look at cosine. So here we have cosine. So our cosine, we're looking for our angle, so there's that angle, and it says AH. So this means we want the adjacent side over the hypotenuse. So our adjacent side is going to be right next to it. Adjacent means your neighbor, so adjacent is side by side. And then our hypotenuse is across from the right angle, always, every time. So with these, we want to see what's right next to it and what's across from the right angle. So first, we find our angle. So here is our angle, and we see it's asking for cosine of this angle. So I know cosine, ca, is adjacent over hypotenuse. So for adjacent, this time I'm looking right next to it. So adjacent to that is 12. And then our hypotenuse is across from the right angle. So this would be 13. So here, 12 over 13 is my final answer. All right, number 2. Again, we look for that angle. So here's y. We want cosine. So that means we want adjacent over hypotenuse. So if I look adjacent to my y, here we've got 36 right next to it. So for adjacent, I'll put 36. And then for hypotenuse, again, I want across from the right angle. So across from the right angle is 39. Again, we can put this in the calculator. If you put it in the calculator, it'll give you a more simple answer of 12 over 13. Yes, it's the same as the one above. So again, you can do 12 over 13. You can leave it at 36 over 9. They're the same answer. All right, we've got one more to look at, tangent. All right, so with tangent, this is the one that does not have the hypotenuse. So tangent is TOA. So we want the opposite side to go over the adjacent side. So when we look, here is my angle. Our opposite side is across, and our adjacent side is right next to it. So you can still look and find the hypotenuse across from that angle, so you know, nope, I do not use the hypotenuse. So let's look at our first one. First we find our angle. So here is our angle. And I'm going to go ahead and look at the hypotenuse. So here is my right angle. Across is 26. So for tangent, if we remember, we want opposite over adjacent. So I do not need to use 2.6 this time. So I'm going to cross it out so I don't confuse hypotenuse with the adjacent side. So now I can look across from x and I see 2.5. And then I can look adjacent to x and I see 0.6. And then it asks us to reduce. So if we look at our calculator, which I did not have open, so it'll be a second. I can go to alpha y equals, enter to get the fraction, and then let's see, we've got 2.5 over 0.6, and if we press enter, we get a very crazy fraction. So let's see if we can get a nicer number. If I do alpha y equals, if I click number 4, it'll change it back to a fraction. Let's see, it says 25 over 6. So here we could do 25 over 6, or we can put this decimal, 4.16. They're the same thing. All right, we've got one more. It's asking for both tangent x and tangent y. So this means tangent x, we're going to look at the x, and for tangent y, we're going to look at the y. So first, I'm going to remember tangent is opposite over adjacent, opposite over adjacent. So that means there is no hypotenuse. So my right angle across from that is 25. So I'm going to X out 25. I do not need 25 for these fractions. So if we start with x, I want opposite x. So opposite from x is 7. And then adjacent to x is 24. So this tangent x is 7 over 24. Then if we look at tangent y, for y, I want what's across from y, which is 24. And then I want what is adjacent to y, which is 7. So for tangent y, it's a flipped fraction, 24 over 7, because we're looking at the other corner. So you need to be careful to watch where is the angle that they gave me and what sides do I need. So that's where it can get a little confusing, is knowing where each angle is and what sides you need. All right? So go ahead and try the practice, see how you feel with putting numbers in fractions, and then let me know, or Miss B, if you have any questions. Good luck.